Good morning, everyone. Today we will be presenting on instruments of resilience, equipment and systems used in the times of earthquakes. So, what is an earthquake exactly? An earthquake is a sudden release of energy in the Earth's crust that creates seismic waves. These seismic waves release energy which causes the ground to shake, sometimes mildly and other times with severe destructive consequences. Most earthquakes occur due to the movement of tectonic plates that are present in the Earth's crust, which fit together as if in a jigsaw puzzle. As these tectonic plates move slowly over time, stress builds up along their boundaries. When this stress is suddenly released, it results in an earthquake. So, earthquake occurs along faults, which are fractures or cracks in the Earth's crust where movement takes place. This is where there are three main types of faults. First is the normal faults. This occurs when the rocks move apart due to tensional forces. Second is the reverse faults, which occur when rocks are pushed together due to tensional forces and causing compressional forces. And the last one is the strike slip faults, in which the rocks slide horizontally past each other due to shear forces. Now I pass on to Arnav.
To understand the strength of an earthquake, we measure its magnitude, which represents the amount of energy released. Earlier, earthquakes were measured using the Richter scale, which generally ranges from 0 to 10 or more. However, modern earthquakes are now measured using the moment magnitude scale, also known as the MW. This scale is more accurate, especially for large earthquakes. An important point to note is that each whole number increases on the magnitude scale represents a tenfold increase in the amplitude of seismic waves, meaning even a small increase in magnitude can result in significantly greater damage. One of the most important instruments used to measure earthquake is a seismograph. A seismograph is a highly sensitive scientific instrument designed to detect and record seismic waves. It works on the principles of inertia, where a mass suspended by spring remains relatively still while the ground beneath it moves. The recorded data called a seismograph helps scientists determine the earthquake's magnitude deeply, depth, and the epicenter. Seismographs are used globally in semiological observations and meteorologic and monitoring centers. Now I would like Raghav to continue.
Apart from measuring the earthquakes, the modern technology also helps in reducing their impact through the early warning and structural safety system. An earthquake early warning system is an integrated system of seismic sensor, the communication networks, and alert mechanisms. It works by detecting the initial P waves, by which they travel faster and cause less damage, and then warning the people before the destructive S waves arrive. This system can provide a few seconds to minutes of warning, allowing automated shutdowns of factories, gas lines, and giving people time to drop, cover, and hold on. Another important instrument is accelerometer. An accelerometer is a sensor that measures sudden changes in ground motion along three axes. It records peak ground acceleration, which tells us how fast and how strongly the ground is shaking. This data is crucial for structural engineering to design earthquake-resistant buildings. The accelerometers are commonly installed in buildings, bridges, dams, and earthquake monitoring stations. The structural protection system also play a vital role during the earthquakes. These include the structural health monitoring system and base isolation system. The structural health monitoring uses the network of sensors to continuously monitor the building for damages, stress, and for deformation. After an earthquake, the base isolation system uses a flexible bearing placed between a building and its foundation. The base bearing allow a building to move independently of the ground and great reducing the amount of seismic energy transferred to the structure.
In addition to these systems, shock absorbers are used in many modern structures. These are mechanical, or hydraulical devices installed within the building's framework. They function similarly to the shock absorbers in vehicles by converting seismic energy into heat energy. Shock absorbers help reduce building sway, minimum structural stress, and prevent structural failure, especially in tall buildings, skyscrapers, and long span bridges. During earthquakes, communication becomes crucial. Emergency communication systems are resilient networks that use satellite phones and radio tracking communication. These systems ensure uninterrupted information flow and coordination among rescue teams and normal communication network fields. Search and rescue equipment also plays a crucial role after an earthquake. This equipment includes life detectors, thermal camera, and listening devices. These non invasive tools help locate trapped survivors under rubble by detecting body heat, movement, sound, or breathing, thereby speeding up the rescue operations. To conclude, while earthquakes cannot be prevented, their impact can be significantly reduced through advanced technology, proper planning, and preparedness. Instruments of resilience help save lives, protect infrastructure, and support faster recovery in the aftermath of an earthquake. Thank you.